Hi everyone. In this video, I'd like to focus a little bit more on the graph end of things. So we've looked at some function notation and reviewed a little algebra, and here I really want to get into the whole, if you have a graph in front of you, do you understand what all these different function notation pieces are actually trying to say to you? So I'm giving you this function g of t, and then I have a whole list of things down below, and we are supposed to decide if each one is a length, a slope, or an area. And I have even been more specific. Area of a rectangle is all you're looking for here. And then on the picture, we want to see if we can show each of those things. So hopefully I have enough colors that this is something that you'll be able to see when I'm all done. Okay, so let's see. First pair, we don't need to see that, is what is C and what is G of C. So I kind of hit some of this in the first video. C is a label I see right here on a horizontal tick mark, so it's an X value. But I want you to be really clear about the fact that an X value is a length. So C is the length from the y-axis to that tick mark. It's the distance. So this is a length. And g of c, the thing that we get when we plug c into our function, is the y value. And this is actually kind of a tricky one. There's an open circle, so it doesn't actually stop there. We need to go all the way up to the top. So this is a c, and this is a g of c. And a y value is a vertical distance. So right here, this length right here is g of c. So it is also a length or a distance, however you want to think about that. Okay, so we have two lengths as our first pair. Okay, and then the next set starts off similarly. So if we're looking at D and G of D. Okay, so let's see. I'm going to use pink. Okay, so I see D, another label on the x-axis, which means D is a length. It's the length of this line right here. Okay, so here, I'm just labeling pink down here. So this is a length. And then G of D is going to be this length. And then it gets a little bit more interesting. So G of D is a y value, which is a length. D is an x value, which is also a length. So the next question is, what if you multiply the two? If I multiply a length by a length, the question is, what happens? And the answer is we get an area. Length squared is area. And in fact, they're different lengths, so it's not really length squared. But if you're thinking units, say this was centimeters times centimeters, we get square centimeters, which is an area. In particular, if we take this horizontal length and multiply by this vertical length, what we're going to get, let's see if I can draw it nicely. Hold on, I got turned so I can draw it nicely, hopefully, is the area of that rectangle. So this is D times G of D. Oops, keep going, all of that. Okay, so this is an area. And then last one for this, what is G of D divided by D? So now the question is, what do you get when you divide a length? And I think looking at the direction helps a little bit as well. When you divide a vertical distance by a horizontal distance. So if you think about things we know where we take a distance divided by a distance, the one good one that comes to mind for me is slope. So in this case, if I take this rise and I divide it by this run, what I'm getting is the slope of a line through those two corner points. So through these opposite corners of this rectangle. Okay, so there's my line. And the slope of that line is G of D divided by D. So the reason it doesn't fully look like average rate of change is just because one of the points is 0, 0. So it's really G of D minus 0 over D minus 0 that gives us that average rate of change look. Okay, so at any point, if you feel comfortable, feel free to pause this video and try and work through the rest on your own, and then you can check back and see if you got them or not. And if you didn't, you can just skip to the end and look at all my answers. If you didn't get them, then you can come back and watch and see what went wrong. All right, let's see. See if my yellow pen is good. So D plus 1 and G of D plus 1 and G of D with the plus 1 on the outside. Okay, so I know that D is this length right here, right? This is D. And I'm supposed to add 1 to that. And here's the thing, you shouldn't just be guessing how long 1 is. So I very deliberately labeled 1 for you. So I know this length right here is 1. So we're just going to kind of eyeball it. We're going to take this 1 and we're going to tack it on the end. I think that looks about right. So D plus 1 is that entire length. So it is a length. Let's go ahead and put that down. And then G of D plus 1. This is saying plug X value D plus 1 into G. Whatever you plug into G, it's taking as an X value. So if our X value is D plus 1, that means we're clear out here. And this length right here is G of D plus 1. Okay, and then we're asked for something else. So this is a length, it is a Y value. We're asked for something else. We're asked to take G of D, which is the Y value when X equals D, and add 1 to that. So this is very different. This says go 1 further on the X axis before you look for your Y value. This one says just go D on the X axis, so I'm right here. And then G of D we've already found is this length. And then you're supposed to add 1 to your output, which is your Y value. So you want to take this little 1 right here, different than the horizontal one, and that does matter. This is telling you basically your scale. So we add that little bit on top, and this Y value is G of D plus 1. So all of those are lengths. They're all X values or Y values, but we messed around with them a little. So 1 was add 1 to your X and then find your Y, and 1 was add 1 to your Y. Okay, the last 2 rows are all kind of one big chunk, looking at G of A's and G of B's. Okay, so let's see. I'm going to try and use these green and blue pens and see if that shows up well enough. So here is G of A, and here is G of B. Can you tell that's green and blue? Yeah, sort of. Okay, so there are G of A and G of B are both lengths. They are Y values, right? That says plug something into your function. The thing you get out will always be a Y value. We are then supposed to take B, which is this big, long length right here, and we're supposed to subtract off A. And what's going to be left over is this. This is my B minus A. So an X value minus an X value is just going to be a length. It's a horizontal distance. Okay, so those are basically our pieces. There'll be one more that we work on, but those are our pieces. And now we're supposed to look at putting some of them together. So for example, if you take the length B minus A and you multiply it by the length G of B, so that's this length multiplied by this length, what you're going to get is an area. When you multiply 2 lengths together, you get an area. So here we'll just use blue for this one. And it's the area of the rectangle with base B minus A and height G of B. So this one has area B minus A times G of B. Oh, got off the screen a little bit. Okay. The next one we want is G of B minus G of A. Okay, so we know G of B is a Y value, and we're supposed to subtract off this other Y value. And what we're going to be left with is this right here. So we'll call that G of B minus G of A. Okay, so that is a length. All right, and then we're supposed to mess around with that one as well. So what happens when you take g of b minus g of a, which is a length, and you divide it by b minus a, which is also a length? So we're taking this length right here and dividing that into this length right here. So we got a rise divided by a run. So this looks like definitely it could be a slope. Let me think about what color I could throw in the mix here. I already used purple, but we'll use it again. So from point A, g of A to B, g of B, this is our slope. Here, I'm going to scoot down for a minute. Slope equals g of b minus g of a over b minus a. Okay, so again, length divided by length, it won't always work nicely, but the one good thing that we know that's a length divided by a length is slope. If it's a vertical length divided by a horizontal length, then we can try and interpret it as a slope. Okay, last one is b minus a, which is a horizontal length, times g of b minus g of a, which is a vertical length. What color did I make that one? That was orange. Still have orange. Okay, so length times length is an area again. That's what we had up here. We had a length times a length, but this is a different one. I don't know if you can tell the difference, pink and orange here, but that's what I was going for. Okay, so now we're taking this pink length and we're multiplying it by this little orange length. And we are going to get the area of a rectangle, but it's a different rectangle. So let's see. If we take length times length, this is the area we're going to get. So that one is b minus a times g of b minus g of a. Almost fit. Okay. So let me move down so you can see that whole messy picture. Oh, did I finish writing these in? I don't think I did. This was length, this was a slope, and this was an area. Okay, so there's my whole messy picture, if you can see any of what's going on. So if you did skip ahead, feel free to check that out. Hopefully you can decipher what's what and rewind back if you want to see more. Thanks for watching.